Okay, my name is Irsyad bin Kamil. You can call me Irsyad. Currently pursuing master degree in software engineering at University of Technology Malaysia, and today I will present my research work on a hybrid prioritization research technique in regression testing. This research complete without my main supervisor, Prof. Dr. Dayang Nur Haida Banjawi, and my two co-professor supervisor, Associate Professor Dr. Wasbi bin Muhammad and Associate Professor Dr. Raja Zahila bin Raja Muhammad Wazi. So throughout this presentation, there are 6 chapters that we explain, which are introduction, literature review, research methodology, proposed hybridization method, result discussion, and conclusion. Okay, so what is regression testing? Regression testing is a method where it runs to ensure the modification made does not affect the existing model of a product. In simple words, we do regression by re-executing the test against the modified application to evaluate whether the modified code breaks anything which was working earlier. So anytime when there is a modification, we must do regression. Regression testing are widely used by industries. So there are a few techniques that have been applied by them, which are we test all, test case selection, test seed minimization, and test case consolidation. Test case selection is a technique where it reruns test cases that are relevant to the changes or updates made. Test seed minimization is a technique that seeks to eliminate redundant test case in order to reduce number of test cases. That is why the first place, the name is minimization. It minimizes the number of test cases. So next is test case prioritization. Is a technique that reorders the test cases based on preferred criteria or properties in achieving the objective. And lastly, we have is the most simple and straightforward technique as it executes all test cases without faltering or ordering. So in previous slide, I've shown the definition of each technique. So in this slide, I will explain more on each strength, strategy, and weakness. So without no doubt, we test all, don't have any strategy. But since it executes all test cases, then it should have a high rate of fault detection. And the most obvious weaknesses are the technique is costly and require a high effort. Next is we have test case selection. It is a strategy. Its strategy is to select test cases that are relevant to changes made. Since it succeeds on narrowing the number of test cases, then the testing will be less cost and less time to finish testing. Meanwhile, test minimization have similar strategy with test case selection, where it eliminates test cases that are redundant or similar. If the amount of test cases reduce, then the amount of cost will also reduce. However, but the rate of fault detection will also decrease due to its strategy of eliminating test cases. And lastly, we have test case prioritization. It prioritizes and orders test case based on certain criteria. After the test cases have been ordered correctly, the technique will be able to detect faults easily. Since the number of test cases is not decreased, the technique will definitely consume time. However, these techniques' weaknesses will be different depending on the approach used by the tester. For example, if we apply a model-based approach on TCP, then we wouldn't have to look into the test cases, but we will have to look more in the model. So in the background study, I managed to quote a few texts from the existing work. So the first one is test quality becomes difficult to produce and fragile as the complexity of a system will generate new problems. This is one from Thiel and Flaws in 2014. Next, we have Drew and Riadz in 2016 stated that TCP took a long time to finish, but it is beneficial since the benefits gained from early fault detection are high enough to compensate for the cost and time incurred. However, if the test cases keep changing, the requirement keep changing and the requirements is bigger and bigger as time passes by, then maybe the cost and time incurred would be not enough to compensate. So next we have a statement from Gupta, which is 2017. Simple modular derivative restructure of algorithms are gaining more popularity. Next, we have a single objective approach is not practical because testers normally have many different objectives such as less time, effective, and low cost. This is from Harman in 2016. And lastly is each specified approach have its own advantages and disadvantages. For example, search-based approach tends to minimize coverage so it can complete its execution at shorter period. So these statements, this is the statements that motivate me to run this research. So the first one is to combining two techniques together can produce an optimized technique, which led to the introduction of hybrids. Hybrid technique has higher chance of in delivering better. And this one is from Su. This is very recent, it's 2020. And next is we have one from Mohaltra, who applied test case selection classroom method to TCP in order to increase confidence in the correctness of the modified program. This is one of the hybrid existing work. Next, we have Sampad, who argued multiple criteria could increase the effectiveness of regression test technique compared to a single criteria. The main question for my research is how to get an optimal result by hybridizing prioritization with selection technique in regression testing. So this main question is divided into 4 mini questions. The first one is how to enhance and apply string algorithm on finding the similarity between test cases. Next, how to integrate the enhanced prioritization technique and selection technique. And next, we have what is the process in applying the proposed technique, and lastly, how to evaluate the effectiveness of the proposed technique. As mentioned earlier, multi-objective has proven to be better than a single criteria. So the aim of the study is derived to the research objective. So the first research objective is to enhance string algorithm in calculating the string distance. The second objective is to propose a hybrid technique by merging prioritization, test plans, and apply selection. And the third objective is to evaluate the proposed technique using the primary and secondary. Okay, now we are in chapter 2. Yes. So in literature review, so we have 4 key areas that I will explore today, which is regression testing, hybrid technique, search algorithm, and string algorithm. So for the regression testing, there are 3 existing work that I have reviewed. So in summary, minimization technique enable tester to have options of test cases depending on their budget, while selection technique manage to improve its cost effectively. And for the prioritization, high fault detection capability is achieved. Okay, so for hybrid technique, there are 4 existing work. So in summary, all hybrid sequence gave an impact to their research study. However, TCP to TCS, the first one here, and TCS to TCP is the most efficient since their work emphasized on test efficiency and test cost. So next, we have search algorithm. So I can conclude that each experiment that they represent have different objectives, and the algorithms helps in achieving their research objectives. So we have Firefly, Genetic, and Greedy. And the most recent is from Firefly, 2019. So for the string algorithm, so I've reviewed 4. So there are Levenstein, Jacob, Constance-Sumeti, and Joe-Winkler. And I can conclude that only Joe-Winkler and Levenstein are mostly used in research study and gave a good coverage in calculating the similarity. Okay, next is the research methodology, chapter 3. So and here we have 5 phases. Let's go deep. Okay, for the first phase, research foundation and overview. This is where the research domain, objective, and scope are identified. Followed by making a mapping study, which I made on TCS mapping study, and review an existing work. So the next phase is the research framework and experiment. This is where the research framework are developed and experiment are designed. And also the primary and secondary experiment are identified. So the third phase is the research initial experiment, where experiment were tested using secondary data set. For this one, I apply similarity-based approach to TCP using string algorithm on secondary experiment, and I measured the result using APFD. I evaluate the result using APFD. And based on the evaluation, I propose an enhancement for the string algorithm. So for the next phase is the research final experiment. This phase is the turning point of the research. All framework experiment design are tested here. Initially, I tested using the second data set, using the open source data, which I will explain later on. Firstly, I apply the search-based approach on TCP, and then I measured the PFD, evaluate the outcome with the existing outcome, and then from there I merge the result which I gathered from the result from the previous phase for the similarity base, and then I merge with the search-based test plan. After merging the test plan, I select the test plan using test case selection technique using rate-based approach. The result of this phase will determine the status of the research objective. After finishing this phase, I re-execute this phase from phase 3 to phase 4, but using different case study, which is the primary dataset, smart reject system case study. Okay, next is the final phase of the research, which is the research result and findings. This is where I conclude the experiment and suggested some future work, which led to the completion of the research thesis. So this is the research method. This is the research conceptual design. So as you can see here, there are two contributions. The first contribution is to introduce selection method after merging two test plan generated by test case prioritization similarity based and test case prioritization search based. And for the second contribution is on the string enhancement. So for this, this is the experiment study. The secondary experiment study, this is an outsourced or open source data set. There are 1,608 test cases, and it equipped with the fault matrix. And for the primary study, I use a smart recheck system, which it is fully equipped with camera, Android device, infrared sensors, motorized wheels, and embedded processor with Bluetooth module. This system is built by our degree student for their final year project. So for the evaluation matrix, I use APFD, average percentage of fault detected, and for the statistic test, I use Kuska-Wallis. Okay, this is the fourth chapter, the proposed solution method, and this is the overall hybrid process. So from here we can see that there are three pillars, I could say pillars. So the first one is a similarity-based prioritization approach, and next we have search-based prioritization approach, and lastly we have weight-based selection approach. So from here we can see that the prioritization technique are executed first. Only then we can merge them and apply the weight-based approach. So the this is the proposed hybrid string matrix. So this is a burger diagram. So from here we can see that the Java-Winkler have been injected with Jakarta index to form a new enhanced Java-Winkler distance. The proposed string metric here, the first method was splitting the Java-Winkler into Java similarity and Winkler equation. This process was inspired. I was inspired by the Winkler, the one who enhanced the Java similarity to form Java Winkler. So I just copy his method and just simply inject with the checkout by substitute the matching characters from checkout and modify the total characters to match with the transposition which covers the Java similarity. Okay, this is the overall prioritization process for similarity base. So originally the test case inputs are not the one that we understand. So first I apply the cleaning program, and then from there I can generate a test input test strings. So from there I apply the string algorithm to find the similarity. So after calculating the similarity, I apply the prioritization program so that I can prioritize the test cases. To evaluate the result, I evaluate by calculating the PFD value with the fault metric that has been provided by the open source. So this is the test case traceability. So this is how I calculate the similarity. So for example, let's say we have like 5 test cases. So that means that I have to iterate for like 25 times so that I can cover all the similarity between test cases. And on the right side here is the prioritization process, where how I prioritize the test case similarities. I simply use the FIFO method, first in, first out. So next, this is the search-based prioritization approach. So in this search-based, I use generative algorithm So in general, the generated algorithm begin by generating the initial population, complete fitness, and then it selects crossover, mutation, and complete fitness, and it will keep looping until the population has converged. So next is the generated algorithm process in TCP. So this is the the GA process. So again, it generates population, it calculates fitness score, and if the score passes, it will end the program. But then if it does not end, but it does not pass the score, then it will undergoes crossover method, and then mutation, and then it will keep looping, and then until the end. So here I'm going to show you an intro on how I work on it. So this is the an example of the 5 test cases, 5 sequence, sorry. So like sequence 2 here is the chromosome, and T5 the gene, and the total sequence is the population. So this is the test, this is the demonstration. So here we can see that C4 and C1, it has the highest and second highest. So I quickly take it and move it to the next. So over here, I simply set a crossover point. So from there, I can exchange genes between each other, and from there we can set a new offspring, and this new offspring will combine with the next population. So if there is a duplicate between the test cases, the mutation phase will be executed. So this is the TCP again, the TCP process on the search page. Search base, so I clean the program and then search the best test plan and so on. Okay, right. So this is the weight average scoring method. So here I apply weight base. So here we have two parameters. We have fault rate and similarity. So but then we have 3 options. We have fault based scoring, similarity based scoring, and balance based scoring. This is the Michi strategy. So basically in this example, I just similarity base is have the higher weight, meaning that this is the reason why the similarity base is on top of the test plan is. So this is the demo. So this data set has been retrieved from similarity based prioritization technique and search based prioritization technique. So this is the first option. We have the similarity based scoring, since it's benefits to the similarity, meaning that the merging result will the result from the similarity will be on top of the weight on the search base. For the second option, we have fault-based scoring, meaning that the test cases from search base will be prioritized rather than similarity base. For the balance base, this one is a bit tricky. So I calculate the test plan by calculating by subtracting the length of test plan with order of test cases and times with 50. So let's say if test case T0753 similar with T0753 on search base, I will randomly choose which one is more priority. Then this is the final result lah. Okay, so this is the TCP and TCS process by applying weight-based approach. So from the data set, I extract and clean it up and calculate all the test plans and select and evaluate with the FFT value. Okay, so we are here at the result and discussion. So this is the result for the test case proportion in similarities, but then this is for secondary experiment. So from here we have the enhanced job place on this is the blue color. So here we can see that the enhanced job clear is maintained. It doesn't show any drastic changes, meaning that the result is satisfied. Okay, so here is the result. Okay, from here we can see that the cosine similarity has the highest FAFD compared to others. However, enhanced job clear managed to get one highest also, but then only for 1 point KCS. Okay, next we have the search-based prioritization approach. So from here we can see that as the number of generation increases, the FAFD value increases. So for the FAFD value, since it prioritizes based on fault detection capability, then meaning that it is possible to have the maximum fault detection rate. So here we can see that every FAFD, all FAFD are managed to get at least to 90%. This is the weight-based selection approach where the search-based and similarity have been hybridized. So based on here, we can see that the balance base has covered more higher IPFD compared to others. So this is the balance based on IPFD. So here we can see that the balance clearly is the winner for this experiment. Okay, many might be wondering why is the fault similarities does not give a high IPFD since it prioritizes fault. The fault is prioritized before the fault is prioritized based on number of test cases. When it combined with similarity, so the number of test cases have been increased. So when it increased, so when we calculate the IPFD value, it shows much lesser value. So this is the TCS in summary. So the result in summary. So we have here test case coverage with IPFD. And then for test case coverage, the highest should belong to the similarity base since it runs every similarities. So search base runs only 37%, but then it has the highest IPFD. So for the hybrid system, it is I could say it is balanced because it covers 70% of test coverage while maintaining a good IPFD. So this is the summary. So for the number of test cases, okay, this one is I use for the polynomial experiment. So this is the test case proportions. The blue color is the enhanced Winkler. Okay, this is the IPFD value. For clearly the winner is the enhanced Winkler. Again, the number as the number of generation increase, the IPFD also increase. And for the mean value IPFD, it covers almost 96%. So for the hybrid system, for the balance, we managed to get until 80% for the balance part. Okay, next is the summary of the results. So we have weight base at 77% of test case coverage. Again, I am quite satisfied as the result is satisfied because even though it does not cover a huge amount of coverage, but then it maintains its IPFD rate compared to others. So here we can say that hybrid technique may not cover the most of the test cases, but its fault detection rate is high enough to balance the result. So here is the normality test. So the null hypothesis is rejected if the p-value is below 0.05. The null hypothesis in proposed technique are accepted, but other techniques are rejected. Since the histogram does not show any bell curve, so it proves that the data based on the result is not normally distributed. Therefore, non-parametric method Kuskawa-List will be used. So this is the non-parametric test. So from here we can see that all the technique pair are significant. So in this discussion, so we have in terms of PFD, TCP with search-based approach accumulate the highest score. But in terms of coverage, TCP with similarity based covers most test suite. So the proposed hybrid managed to get a high IPFD score with size of test suite reduced, proven to be cost effective. So the third one is the data from the case study is not normally distributed. The analysis is based on the Z value of skewness and kurtosis, sharp pre-over test, inspection of bell curve on the shape of histogram, and for the post-hoc analysis, it showed significance on each pair of the comparison. The proposed hybrid technique is statistically significant when compared to other techniques. The proposed hybrid technique is effective in solving research problems of covering more test cases while maintaining a good IPFD score. So in conclusion, so all research objectives have been achieved. So the first objective is the enhancement did improve the IPFD score for Winkler. And then the second is the emerging strategy was introduced. Results from the proposed technique are satisfied, evaluate with primary experiment. So in terms of contribution, there are two. The first contribution is enhanced Winkler proved to be successful in terms of IPFD score after implementing in 8 on 3 same data set and one case study. And the next contribution is hybridization systematic process has been introduced and proven successful in terms of FPFD scores and test case coverage. And for the future work, I plan to apply test case generation before executing proposed experiment. And finally, I wanted to apply Google search algorithm to search list similar string and to produce an optimal result in the process. Okay, that's all for today. Thank you for listening. Let's proceed to the Q&A session. Thank you.
Thank you, Mr. Irsyad, for the presentation. Now we start the Q&A session. If anyone has any question about the presented research just now.
Oh, sorry. Maybe next time I will try to shorten the introduction. Thank you for the insights, Kak Shifa.
May I know what the type of fault you use? Is it seeded fault or real fault?
The fault matrix. I think it's the seeded fault. The one that we obtained from the data set. That's a good question, actually, don't mind. I think it's a seeded fault.
You take from what's the website? I forgot the name.
The same as the software infrastructure repository. So
did you mention what you use as the fitness value for the genetic algorithm?
Okay, for the genetic algorithm, I measured APFD. So every time when the generative population had been created, first thing I did was the calculating the APFD. So let's say if the APFD does not reach the benchmark that I put, so the genetic algorithm will keep looping until it reaches the benchmark. And for your information, the benchmark I put for this experiment is 0.9. 90% of fault detection capability.
So the fitness value is the APFD.
Yes. And I put at least 90%. As long as it reaches the 90%, and the experiment will end it.
And the chromosome is the ordering of the test cases.
Yes. Correct.
Assalamualaikum.
Waalaikumsalam, Doctor.
Okay, sorry if there is someone asking the same question before. I just want to know about your test case prioritization. From the presentation, I see that using your your string distance alone has improved the FPFD. So why do you include the second part, the combination with the search-based algorithm? You can explain.
All right. Thank you, Doctor, for the question. So let me show you the result here. Okay, this is the result for the similarity base. So from here, we can see that the APFD is raised from 0.581 to 0.671. But then for me, I feel like this is not enough. So my aim is to target at least to 90%. So that's the reason why I plug in the search-based prioritization approach, which is also why I presented the hybrid technique, so that at the end of the experiment, I could at least get the 90% of APFD rate. Because here it's just 67%. So for me, I feel like it's not enough, because my aim of the research is to get the highest APFD rate, and while cover a good amount of testing. Does that answer your question, Doctor?
Okay, thank you. One more thing about your contribution.
Yes.
Before that, so your hybrid is about hybridizing the both the string distance and the search base, or is it including that both? So your title is can I see your title back?
It's about hybrid prioritization with selection technique.
With selection technique. Okay.
Yeah, if we look into the diagrams, wait, let me show. Okay, from here we can see that the prioritization technique is on the first level. So after the prioritization technique have been executed, so on the next level, on the second level, I apply the selection technique. So I guess it is what it is, why we call it hybridization prioritization with selection, maybe.
But basically, yeah, it's here. Basically, hybridization for the TCP with test
Yes,
case
yes.
selection. So
Yes.
so basically, you are going for two qualities, the coverage and also the fault.
For yes.
Okay. So when you combine this together, did you get both qualities achieved or not?
Okay, that's a good question. Let me share you the result. Okay, here. So from here, we can see that the test case coverage has the highest is at the similarity-based approach, because the similarity-based execute every similarity. This is why this coverage, it covers everything. But then for the hybrid, it only managed to cover for like 77%. However, the APFD is actually good enough, because if you compare to the TCP similarity base, the approach will only manage to get 71%. So at least I could like increase the APFD while decreasing the coverage, which is in conclusion, we can achieve a cost effectiveness technique.
But I don't know if I mistaken, but when you show this one, the technique is only you show the comparison based on one by one technique. TCP using, is it TCP using similarity and search base, or TCP similarity base is 0.713 and TCP with search base 0.99 APFD, right? But when you use proposed hybrid, TCP with TCS, or proposed hybrid similarity, what do you mean by 0.820? Is it achieved by just weight base, or all with the TCP and with TCS?
Yeah, it represents the whole experiment. It covers the similarity base and the search base, merging, combining, and select using the weight base.
But the comparison, is it what? Is it a wait, I try to find the correct sentence. Is it the correct comparison? Because the first one you compared with TCP only. The second one is TCP with TCS. Of course, should be TCP and TCS higher alone compared to TCP alone, right? So should you compare it like that or not?
Maybe I'm open to suggestions. So if doctor feel like I should compare to the existing hybrid, maybe I should include it on my next viva.
Because
What do you think,
you
doctor?
said your hybrid is in TCP. It's not your hybrid including the TCS, right? Your TCP only is hybrid. Your TCS is with the selection. It's not including in the hybrid, right? Is it?
TCS is included in the hybrid,
Include the
doctor,
hybrid.
because
Oh, because
because
the
I
title
select
is
test cases. I select test cases based on the combination test plan from the TCP similarity base and TCP search base. So I mean, if you could
look into the
go
title
back,
back.
if you could go back to the title.
Hybrid prioritization. So prioritization is hybrid, and you include the selection technique. So
I see
maybe
what
I
you
don't know.
mean.
Maybe I'm wrong, but your comparison now just now is about TCP only compared with TCP with TCS.
And TCS.
Is it a good comparison, or should you just put TCP with string base only, TCP with the search base only, and the result TCP with both string and the search base. Should be like that, or should be the one that you shown just now?
I don't know. I don't know how
I
to
want to
answer.
know.
I don't know how to answer the question. Maybe doctor can show me the light something.
I also want to know the light. Okay. So basically, that's the one that I'm trying to understand, because based on the title, I see the hybrid is for prioritization, and you include another technique which is selection for your regression. But unless you said that with prioritization and selection technique, both are hybrid, is it? Or just the prioritization is only hybrid?
Just the prioritization.
Okay. So I think the table just now, I don't know, maybe you can discuss back with your supervisor. Is it the correct comparison? Can I see back the table just now?
Yeah, that's fine.
Okay. So this is the result summary based between all approaches. All approaches.
Correct.
So all approaches meaning what?
TCP with similarity versus TCP with search based versus hybrid. Is it? Maybe I'm sending the wrong message here from the title. Or maybe on
Or maybe
how I
about
present.
this diagram only, this table only, the title is okay.
Maybe
So this table. So maybe maybe you can put not TCP similarity based. How can you? I'm not sure. But
yeah, me too.
what about others? Can do you see it? What do you see it different from me, or is it okay for you? Others? We can discuss about this. Maybe I'm
Yes, please. Let's discuss.
Mhm.
Since this is about viva.
Yeah.
So doctor, you mean the proposed one has test case selection, the above one don't have test case selection, like that.
So
It's like not fair comparison.
For me lah, not fair comparison.
So yeah, maybe do you have Irsyad, maybe is there similar approach like you? I'm not sure it's enough time. Just a suggestion.
I mean, if I apply the web base after executing the similarity base, it won't be what you call it numb, because similarity is the results is always prioritized. So if I apply web base, and then it would be like which is the test case will be higher. So I mean, for web base it helps because when it comes to choosing two parameters, so maybe we can select similarity. Maybe we can say for. So this is why I apply the weight base. So if I wanted to apply the weight base on the similarity base, I don't think it is applicable. But maybe like Roman said, maybe I should add on existing work, I guess. But then the time
existing approach like what you propose, just maybe future work.
Yes. I feel like maybe I should try something out. Okay. I will take it note from that. What about the what about if I included?
I'm so sorry. I just get so this result is to show which objective, to prove which objective.
Not the second one, doctor, on the hybrid method.
Hybrid method. So hybrid method should be you compare TCP with similarity base alone, TCP with search base alone, and then you compare TCP with both similarity and search base. Cannot be like that without the TCS.
But then if if I remove the TCS, then it would be a hybrid method.
So meaning that your hybrid is for those three, right? It's not only TCP. So TCP with TCS also you claim as hybrid lah. Now your hybrid is about TCP plus TCS. You see? Your hybrid is not about similarity based hybrid with search based. Your hybrid is about TCP with TCS. Yeah.
Yes.
So my first question just now, meaning you should answer, it's not about hybridization of two TCS approaches. It should be hybridizing TCP and TCS.
And that's summarized. Sorry, doctor. Sorry.
I don't know, maybe lah. Meaning that your hybridization that you are mentioning just now is about TCP plus TCS.
Yes.
It's not you hybridizing solely on the TCP only. Similarity based with the search base. Sorry, similarity with the search base. You said hybrid that too only. Now, if you say it like that just now, so meaning that you are hybridizing TCP with TCS.
Which is.
So which one do you hybrid actually? Can I see your research methodology? Which one do you hybrid actually?
No, I mean if you look into the diagram here, so let me show you the diagram. So here we can see that the call it. Sorry, let me draw something.
So all of it is hybridization method, eh? The proposed hybridization method. TCP plus TCS.
So here is the prioritization technique happens, and then so here is the prioritization happens, and then the prioritization happens. Both transport prioritization will give a test execution test order. So both test execution test order, both test execution test order will be merged to form a new test plan, and then I apply weight base to select which is the test plan who are the most suitable for the next phase. I guess this is what we call prioritizing TCP and TCS.
No, hybridizing. Yeah, TCP
hybridizing. Sorry, hybridizing TCP and TCS. Because the first level here is the prioritization, and the second level is the selection. And also this diagram is actually I inspired from one of the research existing work, which is recently who did it the same, but they implemented differently. They applied TCS first, only then they applied TCP. But in my case, I vice versa.
So meaning that is it with hybridization that you are mentioning, is it only on TCS or is it combining both techniques? TCP and TCS.
It's combining.
Okay, that one. And another one, your contribution is the process. So which is the process? Where do the process contribution shows in your slide?
In the merging, doctor. In the merging strategy, because it is new.
Merging
because
of the prioritization and the selection.
Yeah, the merging. Let me show you much clearer version of the diagram here. Wait, is it here? No, it's not here. The other one. Yeah, this one. So here we can see
can
that
you show your slide? Display.
Show.
Display. Apa tu? Display yang kat bawah tu.
Oh, sorry. Sorry. So here we have the original test case input, which will be used for the similarity base. And then down here we have on the right hand here we have the fault matrix cheat sheet, which will be used for the search based position method. And then
why do you call it cheat sheet?
Because for the search base I only use cheat sheet. It's not cheat, actually it's
like main game lah.
bukan cheat apa main game pula. I think it's a typo here. It's a typo there. I will fix the typo.
No, the name is not cheat sheet. In your thesis, you call it cheat sheet. also, kan?
That I need to reconfirm it later.
Okay.
Okay,
So this is
moving
all
on.
the
So
process contribution lah. Okay. So
yes. I mean, if you can see it here, for the first process we calculate the similarity, and then the next process we search the test plan. So here we have the 2 test plan from each experiment for the similarity and search space. So from there, I merge and select test cases using weight scoring. So this is where the contribution of my research. The merge test, which form the merge test plan.
okay. My question has already been answered. Okay, thank you.
Okay, thank you, Doctor, for bringing it up. I will try my best. Maybe on the result, I've already taken note on the result table. So maybe after this, I will discuss with my supervisor on the next path, I guess. Thank you.
Thank you, Dr. Shaliza, for the question. And also, thank you again, Mr. Irsyad. We wish you all the
Thank
best.
you.
All the best, Chad.
For your viva.
Okay, thank you, everyone.
If there's nothing else, I guess we can end our colloquium for today. Thank you, everyone, for joining today. Have a great day. Stay safe, and see you again in the next colloquiums. Assalamualaikum, and may leave the session.
Thank you. Assalamualaikum.
Okay, thank you, Doctor. Thank you, everyone.
Okay.